What is a reciprocating hermetic compressor? A reciprocating hermetic compressor is a type of positive displacement compressor commonly used in refrigeration and air conditioning systems. In this compressor, both the electric motor and the compressor mechanism are sealed together inside a welded steel shell. Because the unit is completely sealed, refrigerant leakage is minimized, and maintenance requirements are very low. The term reciprocating refers to the back and forth motion of the piston, while hermetic means the compressor is fully sealed and not serviceable from the outside. Sealed design and construction. In a hermetic compressor, the motor and compressor share the same housing. The steel shell is factory welded and airtight, which prevents refrigerant leakage and protects internal components from dust, moisture, and contamination. The electric motor operates inside the refrigerant environment, which also helps cool the motor during operation. Due to this sealed design, hermetic compressors are compact, quiet, and highly reliable. Main components of a reciprocating hermetic compressor. A reciprocating hermetic compressor consists of several key internal components that work together to compress refrigerant. Electric motor drives the compressor mechanism. Crankshaft converts the rotary motion of the motor into reciprocating motion. Connecting rod links the crankshaft to the piston. Piston moves up and down inside the cylinder to compress refrigerant. Cylinder houses the piston and forms the compression chamber. Suction valve allows low-pressure refrigerant vapor to enter the cylinder. Discharge valve releases high-pressure refrigerant vapor to the condenser. Lubrication system ensures smooth movement of moving parts and reduces wear. Working principle of a reciprocating compressor. The reciprocating hermetic compressor works on a four-step compression cycle, driven by piston movement. 1. Intake. Suction stroke. When the piston moves downward inside the cylinder, the suction valve opens. Low-pressure refrigerant vapor from the evaporator enters the cylinder. 2. Compression stroke. As the piston moves upward, the suction valve closes. The refrigerant vapor is trapped inside the cylinder and compressed, which increases its pressure and temperature. 3. Discharge stroke. When the pressure inside the cylinder becomes higher than the discharge line pressure, the discharge valve opens. High-pressure refrigerant vapor is pushed out of the cylinder and sent to the condenser. 4. Expansion system process. Although expansion does not occur inside the compressor, the compressed refrigerant later passes through the expansion device, where its pressure and temperature drop before entering the evaporator again. This cycle repeats continuously as long as the compressor is running. Operating characteristics. Reciprocating hermetic compressors are known for their high volumetric efficiency, meaning they can compress a large amount of refrigerant relative to their size. They are especially effective in systems that require high pressure ratios and stable performance under varying load conditions. Applications. Reciprocating hermetic compressors are widely used in both residential and commercial applications, including domestic refrigerators and freezers, small and medium-sized air conditioning units, commercial refrigeration systems, medical refrigeration equipment, beverage coolers and display cabinets. They are commonly used in the 1.5 to 6 horsepower range, making them ideal for small and medium cooling capacities. Advantages of reciprocating hermetic compressors. This type of compressor offers several important advantages. High reliability due to sealed construction. Minimal refrigerant leakage. Low maintenance requirements. Good performance at high pressure ratios. Compact size and quiet operation. Long service life in harsh operating environments. Limitations. Despite their advantages, reciprocating hermetic compressors also have some limitations. Not repairable due to sealed design. Less efficient for very large cooling capacities. Higher vibration compared to scroll compressors. Industry example: Copeland Hermetic. Reciprocating compressors. Copeland Hermetic reciprocating compressors are widely used in refrigeration and air conditioning systems. They are known for energy efficiency, durability, and stable performance in small and medium capacity applications. Conclusion: reciprocating hermetic compressors are a reliable and widely used solution in refrigeration and air conditioning systems. Their simple working principle, sealed construction, and strong performance make them ideal for domestic and light commercial applications. Understanding their components and operation is essential for every HVAC technician.